Hello, my name is Mrs. Salisbury, and this video is going to cover some general strategies for solving logarithmic equations and solving exponential equations using logarithms. If you are currently in my Algebra 2 CP class and you have made the foldable we made in class, then it might be beneficial for you to skip ahead to the solving portion of it because I've added some examples to supplement the foldable that we made. Otherwise, if you're not in my class or maybe you weren't here that day, you might want to watch the entire video. So the first thing that we want to make sure you understand is that logarithms are inverse operations of raising something to the exponent. And so let's talk a little bit about inverse operations and make sure we really understand from Algebra 1 what those do so that we can realize that logs work in a very similar fashion. So remember that inverse operations undo each other, and this is why we use them to solve equations. So for example, addition and subtraction undo each other as long as we're adding and subtracting the same number. So if I have, for example, the number 7, I can add 10 and then subtract 10, and I get right back to what I started with, right back to 7. Same with multiplication and division. If I'm multiplying by 10 and dividing by 10, I get right back to 7. So notice that for the undoing to work, it's got to be the same number. We also have squaring and taking the square root. As long as we have the same root and power, they undo each other. So if I square 7 and then I take the square root of it, I'm right back to 7. Logs and raising a number as an exponent, as long as we're using the same base, are inverses of each other. They undo each other. So for example, if I take the number 7 and I make it the exponent of base 10, I can then take the log base 10 and I've now undone what I first did and I'm right back to the number 7. So let's talk about how we use these to solve equations. So remember that when we're solving equations, we always start by asking ourselves, what's being done to x? And then we use inverse operations to undo it. And we've got to remember that when we are solving an equation, whatever we do to one side, we've got to do to the other so that we keep the equations balanced. So, for example, addition and subtraction. So in this equation, x plus 10 equals 12, the question of what am I doing to x is I'm adding 10 to x. So how do I undo that? I need to subtract 10 because subtraction is the inverse of addition. I subtract 10 on both sides to keep the equation balanced, and I'm back to x equals 2. Same thing with multiplication and division. If I have 10x equals 2, I ask myself, what's being done to x? 10 is being multiplied by x. So how do I undo that? I divide by 10. And then the same thing if I'm having x being squared, I can take the square root of both sides to solve the equation. So we do the exact same thing with logs and exponents because they're inverse operations. So for example, let's say I have x and I make it the exponent of 10. So how do I undo that? I now need to take the log base 10 of both sides to keep it balanced, and now I've got x equals log base 10 of 4. You might need to put that in your calculator depending on what the directions say, but you would put that in your calculator and that would be your answer. Now, what happens if I have an equation like this? Same thing. I ask myself, what's being done to x? I'm taking the log base 10 of x. How do I undo that? I make it the exponent of base 10. And remember to do that to both sides. Now, I've got inverse operations. They undo each other. I'm right back to x on the left-hand side. X equals 10 to the 4th. So it's important to understand that what we're doing is not completely new. We've been using inverse operations to solve equations for years now. The new thing is that we have a new set of inverse operations added to our list.